Hey, what is up everyone? Welcome back to another video. In this video, we're going to continue to work through some Pwned Labs. Specifically, we're going to cover this lab, command injection to EC2 user data privilege escalation. All right, a lot of stuff. Let me say it again, command injection to EC2 user data privilege escalation. Now, full disclosure, usually I work through labs completely live and stumble my way through them. I have done this one previously, though it was a while ago, so I'm pretty sure I'm gonna forget most of the ways on how you do the lab, and I'll still stumble my way through it anyways. But when I did it, I remember really enjoying this lab. It's a little more complex than some of the other ones, and you learn a lot of different AWS functions and privilege escalation paths that you don't learn in some other labs. So without any further ado, let me share my screen. I already launched it, but command injection to EC2 user data privilege escalation. That's a big name, but let me go ahead and start a tab here. We'll just call this EC2 command injection. Yeah, we'll just do that. That's fine. And let's begin with our scope. So what is our scope? Here's our scenario. So after a successful smishing attack, that's text message phishing, huge logistics, you've obtained AWS credentials for a user account. How the heck did I get those through smishing? That's crazy. Your task is to use these initial credentials to explore and possibly expand your access within their cloud environment. Your objective is to determine impact of smishing the user. Let the hunt begin. All right, word. Grab our access key ID and grab our secret. And we'll do that. And we can already tell it's going to have stuff to do with EC2. So let me introduce you guys to a cool tool called Paku. Paku is developed by the greatest, well, not this one. Paku is developed by the greatest pen testing firm on the planet today, aka Rhino Security Labs. But what is Paku? Paku is an open source AWS exploitation framework. Think about like a Metasploit for the cloud, designed for offensive security testing against cloud environments. Created and maintained by Rhino Security Labs, Paku allows pen testers to exploit configuration flaws within an AWS account using modules to easily expand its functionality. Current modules enable a range of attacks, including user privilege escalation, backdoor of IAM users, attacking vulnerable Lambda functions, and much more. So let's go ahead and get this installed if I don't already have it. That's from our previous lab. EC2 hey, I already have it installed, but if you don't have it installed, super easy, pip3 install Paku. That's all you gotta do. But let's go ahead and configure our keys right there. So we'll do AWS configure profile. I don't know what to call this. Maybe smishing. We'll call it smish. And we'll grab our access key ID. Secret. All right, and now we'll do AWS STS get caller identity, which if you're new to AWS is kind of like the who am I using the AWS CLI. And we'll do the profile smish. There we go. So we're at least authenticated. Let's go ahead and grab that for our notes. We are the Ryan user. Oh, good call, Bottleneck. Bottleneck said maybe the smishing message can include a link to a fake AWS website that harvested the creds. Sure, you might be spot on there. Did I just hear one of my kids? Lisa over on LinkedIn said, when I say a minute, she's like a speck. I think that's my... Let me see if my wife's awake, though. My kids are kind of sick. I think that's my son calling out. I might have to pause the stream. Give me just a second. I think my wife might be going to his room. Okay, I'm gonna leave one ear off my headphones in case I have to pause the stream real quick and go make sure my son's good to go. But it sounds like he's chill now. My wife might be in his room. All right, anyways, we have our credentials here. We have our user Ryan, which is right here, and we know it has something to do with EC2. So there's a few things we can do with EC2. I might screw up the syntax. Matter of fact, I probably will. Gosh, is it AWS EC2 describe instances profile? Let's try US West 2. Okay, sweet. So I kind of guessed the region there. There's different regions in AWS that resources can be stored in, so we have it there. But let me show you how you can do the same thing with Paku. And so we'll launch Paku. We will do a new session, and we'll call this one Pwned Labs. And the first thing we need to do is import our keys from that profile we set out. So we'll do import keys smish. And if we go ahead and do, like, we know it's EC2, so search EC2. We have exploit, persist, and enum. So here's the enum one. We can do EC2 enum and just see if we can enum the EC2s in the environment. So we'll run EC2 underscore underscore enum. And we'll just do all the regions, because I kind of guessed it was US West 2, but we don't know. So we'll just go ahead and say yes, run it on all the regions, and let's see if we can find that EC2. And Gromit said, are most of these labs for AWS? I think that's where they have a lot of labs, but they cover AWS, Azure, and GCP. So they have all three of the big cloud platforms covered for labs. Make sure I'm not missing anything on LinkedIn. LinkedIn's annoying because it doesn't show me all the comments. Like, LinkedIn needs to really fix their live platform. So shout out to all you on LinkedIn. If I don't see your comment right away, it's because LinkedIn's weird. Now I see your comment, Lisa. So I apologize if I don't see it right away. Even though I refresh it, sometimes it doesn't show up. I haven't been following this. Has it found anything, y'all? We'll just let it run through. It shouldn't take too long. It's just going through all those regions and basically running that describe instances. Lisa said, we are still here. Sweet. Now I'm seeing your messages, Lisa, so that's good. Glad I'm seeing them. Yeah, we got like 20 people on Twitch, 13 on LinkedIn, about 10 on YouTube. So 20, 32, about a little over 40 people hanging out. So what's up? Hi, everyone. Appreciate you taking the time to hang out with me. Paku's slowly doing its thing. Could just stop it. I bet it found the instance. Where's US West? Oh yeah, US West is right there. I'm sure it found it. We'll let it keep going. There, it's done. So one total instance found. And now if we open a new tab, we're gonna name this one Paku. We can actually look at the data. So if we do, I think it's Paku session smish, or not session, Pwned Labs is the name of our Paku session, and then data and EC2 data. There we go. So then we can see the data that it got from the EC2. And from here, if you're new to AWS, EC2 was just the weird language AWS uses to describe a virtual machine. So could be a web server, could be a different kind of server, but we see on here, we have a private IP, and I am on the Pwned Labs VPN, so hopefully I can hit this IP. Let's go ahead and grab that. There's nothing else interesting here, at least in the environmental variables. Can I ping it? And I can. So let's do Rust scan -A, and I think it's -A to run in-map enumeration scripts at it, and let's just give that a shot. So right away we see we have port 22 open, which is going to be SSH, and port 80, which is going to be a web server. And we should also grab this information for our screenshot, for our notes. And then we have our information here. So let's grab this. All right, there's our InMap scan. We'll drop it there. Make it a little bit bigger. That doesn't look right. Did that do... What was the code highlighting on that? Oh, here we go. That's what I'm trying to do. There we go. And then let's go and just make separate tabs for these as we enumerate it. Once we get creds, we can check out SSH. So keep in mind SSH is open. But let's check out this website and see exactly what is going on, shall we? To every direction. There are many variations of passages of warm ipsum available, but the majority, and then blank. These services, home, about, services, blog, contact, tracking. Okay, let's open up Cato, which I might actually need to update. Let's see if I need to update Cato. We'll do a quick update. Yeah, update available. It might authenticate me, so I'm just going to stop sharing my screen for a second. Oh no, I don't think it's going to do it right away. Wait. And we will do Linux. I have too many Catos. Alright. Okay, now if we do which Cato, we'll just do sudo remove user local bin Cato. And we'll do tar xf Cato on that file we just downloaded. I want to rename it. Oh, not remove, I meant move. Shoot. Come on, Tyler, don't suck at Linux, bruh. Now, move, not remove, to Cato. And now, we'll move to user local bin. Alright. Close it out. Now we should have the updated version. Maybe that didn't work. Oh, come on. Oh, come on, Numlock. What are you doing, bro? Just kill both of those processes real quick and that should fix it. That was user error there. Okay, now we have a fully updated one. We will go ahead and create a project and we will call this Pwned Labs. And we'll go over to intercept, so we have that set up. I like to open it in a new tab here. Just throw it to the side. And now we have our tracker, throw this to the side. Let's go ahead and turn on Foxy Proxy here. All right. Throw that over to replay, turn off queue, and we go to make this big, hit send, and let's just see what a normal request does. Let's render it. So I cannot find shipment number. I'm guessing we're gonna get like command execution through this, but you know what else I bet is vulnerable to is stored cross-site scripting. So this isn't going to be part of the lab, but if you're doing a pen test or a bug bounty, anytime you see a field that accepts input and then returns the data back to the user, you should always see if cross-site scripting JavaScript is possible. And you can do it simple like script alert document.domain script. Very basic JavaScript. And it is. So if we were doing a bug bounty or a pen test report, we would actually make note of this, that it is vulnerable to cross-site scripting. But I don't think that's the main point of this lab. I'm guessing it's going to be like 1, 2, 3, 4, 5. Who am I? Okay, that doesn't do it. Okay, that doesn't do it either. What if I URL encode this? All right, how about, let's do ID instead, actually. So what I'm trying, for those of you who might be new, I'm doing basic like command injection. And I just know these by memory. And there we go, I actually have command injection with backticks. And if you don't know those by memory, if you go to like hack tricks, command injection, so both Unix, so you can actually see the ones I was trying here. And here's the one that worked. So even if you didn't know what you were doing, you could have gone to hack tricks and just tried fuzzing with a few of these, and you would have eventually got RCE here. Oh, so you don't want that open. So, shipment export. So one thing to keep in mind, when you get command injection, we know this is an EC2. You can often, if there's identity, an IAM identity connected to the EC2, which often there is, we might be able to access the creds for that, the access key and secret for that. So let's go to AWS SRF. Here we go. Here's what I'm thinking. So, one of the most common techniques in AWS is abusing the instance metadata service associated with the target EC2 instance. Most can access their IDMS at there. The service is only accessible from the specific EC2 instance, but see, we have full RCE from the EC2 instance, so we might be able to access it. The instance metadata contains useful information about the instance, such as IP, etc., etc. If it has an IAM role attached to it, IAM credentials associated with that role can be retrieved from the metadata service, so we can pivot into the AWS environment. So to demonstrate this, we need to go ahead and do something like this. So we'll go back to Cato here, and we'll do like curl. That we'll back it up to like this, and see if we get anything. And there we go. We have dynamic, metadata, and user data. So one thing to check is if there's any sensitive information stored in user data. And nothing's found. Oh, Tyler, you should go like that, bud. Oh, am I typing that wrong? Is there a dash? There might be a dash. Yeah, there is. Let me double check user data that I didn't miss anything. Okay, no, so nothing's found there. Let's check metadata. Okay, so we have like the AMI ID. What we're looking for is IAM, which I can't see it here. A little easier to see there. So we have IAM there, so let's check that out. And we have security credentials. And we have the name of the IAM attached to this instance, so we'll try compute admin. Grama said, how did you know to try the backticks? Just, it's a common RCE, like in a web app thing that you'll see in CTFs and even in the real world. So I just know it because I've done it enough times. But if you just look up command injection and hack tricks, you can actually follow this, and there it is right there. So compute admin, let's send. Ooh, and there we go. We have the access key ID, the secret access key, and a session token. So now we can actually authenticate as a user in their AWS environment. I totally should have been recording notes for what we were doing up to this point, but too late now. So let's go to our terminal. AWS configure profile. I think it was called compute admin, right? And then you'll notice we still need to put in our session token before I totally cat out credentials. I don't think I would have anything sensitive in here. I have a default one. I don't know if that's for my AWS account or something else I configured. Let's I'm just gonna modify this file real quick before I share my screen. So I don't know what those AWS creds are in default. Just put these ones up here. And save that. Okay, so what we need to do with that session token, this long string that we found here, if we try to do it like this, AWS STS get caller identity, remember that's like the who am I for AWS, compute admin, it's gonna fail. Because it says the security token included in the request is invalid because we're not including the security token. We have to manually add that. So we can do mousepad, home, your username, AWS, and credentials. And you can see our credentials here. Here's our compute admin that we just added. What we need to add is this AWS session token. So we'll do equal there, and we'll grab that from the response. Save that, and let's try that same command. And there it works. So now we are actually in their AWS environment as the compute admin. So now I'm curious kind of what permissions do we have for that compute admin. And because I always forget syntax for cloud stuff, we're going to ask ChatGPT, what are some common commands to check permissions for a role in AWS? You'll see, you guys will see why I forget the syntax for this because it's confusing. So this is pretty basic. We can try that. So we do not have permissions to list roles. Try this on compute admin maybe. Oh, hey. So our role name compute admin, let's go and take a screenshot of this. I don't even know where to add this. We're just gonna go back to this main page since we're kind of doing AWS enumeration here. I have no idea what you're talking about, Ken. Bottleneck said, would you say GPT-4 is worth it? I don't know what it costs. I guess it depends what it costs. My workplace pays for GPT-4, so I don't pay for it personally. I like it. It's a lot better than 3.5 in my opinion. And I use freaking GPT every single day, y'all, especially for cloud stuff. But I did a lot of my whoops, close some stuff out. I did a lot of my earlier labs with GPT 3.5, so you can still do all this AWS stuff with 3.5 from my experience. But you have the ability to assume a role for an EC2, which makes sense because that's what we're doing. I don't know if that's really helpful to us right now. Let's come back to that. let's do this on that role. For the role name, I believe we need the full ARN, maybe. Oh no, maybe it's just the role name right there. So we'll do compute admin, profile, compute admin. So we have our attached policy there. So let's see if we can enumerate that specific policy. Oh, let's also try this as well. Okay, we can't do that. But we can do that. So then to get our policy information, let's just copy this. Oh, here we go. Get policy. AWS IAM get policy. AWS IAM get policy. And then do we just pass it the policy ARN, right? Let's grab this policy ARN. And from our compute admin profile. That's the... Okay, so we have... Okay. We have our policy information here. A default version. I think we can kind of enumerate the policy a little more now with that default version. Yeah, here's what I want. To retrieve the actual policy document, you need to get the policy version, which I have now. So let's give that a shot. Our version ID is just right there, V1. Our policy ARN is right here. Okay, now we're talking, y'all. Let's go ahead and take a screenshot of this. And I'll do my best to walk you through what we see here. All right, before I walk you through it, I want you to do a mental exercise. So try to, even if you don't know AWS super well, look through this policy information and see if you can kind of figure out what this policy allows us to do. I'll just give you a little bit of time to do that yourself first. Struggle through it, see if you can understand a little bit about what's going on here. I'll get a drink. I'll check LinkedIn, make sure I refresh things. No new comments there. A lot more views on Twitch though. Oreo Boy said, how's life? Azure makes no sense. I feel you, dude. Modifying instance. Haircut fish, you are spot on, I think. So here's what we can do. If we look at our policy, like what we can do with this new account, here's the action. Remember, EC2 is just Amazon's way of talking about virtual machines, right? So what can we do? We can describe instances. That means we can list the virtual machines in the account. We can start instances. We can start virtual machines. We can modify an instance attribute. And so we can add user data. And if we look back at the name of this, kind of cheating, but command injection to EC2 user data privilege escalation. So we kind of use a hint that, hey, we can modify instance attribute so we can actually inject user data. User data is like a script that runs when the VM starts up. So we can stop the VM. We can add a script that runs on startup as the root user. And then when it starts, it will run that script as the root user. And then we could privesc in probably a variety of ways there. And then we have the effect allow. We have a wildcard, which means this policy applies to every EC2 in the environment. And then we have some other things. We can get role, get policy version. This is the enumeration commands we were just running on our compute admin role. Yes, Nefos, exploiting cloud init is what it sounds like to me. And hey, if you don't know what this means, the beauty of AI, let's do this. So kind of go in even more detail than what we talked about. But once again, if you're new to this, use GPT. It is a huge help for understanding some of this. I'm going to stop it for now, but we can ask, are there any security concerns with any of those privs? Let's see if it catches what we can do. So they got it in a different way. I suppose we could disable termination protection, which that would be possible. And it does effectively identify like, hey, this is a bad idea. Here's how you can stop this from happening. Okay, cool. But we have code execution on this. Let's go back to Cato, and let's just enumerate the environment. Let's see if we can even get a callback. I think they might have strict security rules in place that it can't even reach out to us. So we'll just do like ls echo hello to hello.text, and we'll do a Python web server. And we'll just see if we can wget from our Python web server to see if we can even hit our endpoint, because that will determine whether or not a reverse shell is possible. But remember, I said in the beginning, SSH is open. We want to keep that in mind. So we could also look at trying to SSH in if we can find some creds. So 10.8.0.8 is our IP, test.text. And we're not even getting a hit. So that means they have a security policy in place, network rules that aren't even going to reach out to us. Right? There's our output. So that's not really going to be a possibility of getting a reverse shell. Let's jump back over to Cato. Let's do something like cat etc password. So we have a non-default user, Ryan, there. Let's go ahead and grab a screenshot of that. If we can compromise a Ryan user, we can at least get on the box. And we'll go back to Cato. Can we do ls home? We have Ryan in Ubuntu. We may not be able to see into Ryan's account. Yep, so we can't see that. Let's just go out to something like opt. Nothing there. Let's check out the root directory. That's not normally there. Everything else is normal, so let's check out that. Well, we have an SSH key, it looks like. So let's cat that. That's probably Ryan's SSH key. And there's our SSH key. Let's go ahead and copy that full SSH key there. Go to our terminal, and we'll nano ID RSA. Drop that in there. I'm not actually sure. I need to fix some of this syntax. Yeah, that's not gonna work. What's a hotkey to fix this? Anyone know? Can I just do that? I don't think that's gonna work. Let's see. What's our target here? It's at 10. Why didn't I save the IP somewhere? just I to specify our key we want to use for key-based authentication. And yeah, I'm pretty sure I just need to fix my key. Control plus that should be it if you highlight. Oh, remove white space on line works too. Let's just do that. Good call. Oh no, that breaks the syntax. Although I can probably fix it. Let's see if that works. Nope, that's not gonna work. That's not correct syntax either. Let's go like this. Sometimes no wrap works on commands. Does it? I know what we could do. Hold up. If I just copy this. Okay, never mind, that won't work. Oh yeah, gotcha, super. Find and replace, remove all the leading spaces. Oh, good call, I might be able to do that. Can we do that with handy little notepad here? Can I do all of them? Look at that. Something like that. That might work. Boom! I fixed it. Okay, now let's just switch over to Bash. Alright, so we have our Ryan user here. We have his AWS creds, but we already have access to his. Remember, our first user was Ryan, so these aren't going to be helpful for us. And we don't have his password. And remember, bottlenecks. So I just learned that Mousepad can do that too. Me too. We learn as we go. Remember, we have access to this compute admin role, which allows us to modify instances, but I don't know the freaking syntax for that. So let's go to like AWS user data privesc. If an adversary has access to the modify instance attribute permission, which we do, they can leverage it to escalate to root or system on an EC2 instance. Usually user data scripts are only run the first time the instance is started. However, this can be changed using Cloud Init to run every time the instance restarts. To do this, first create a file with the following format. We don't need Paku anymore. Actually, let's test Paku real quick. Pwned Labs, import keys, compute admin, search EC2. And then can I just pass it as script? Let's just test this. Okay. And the instance ID. Let's see if I can use Paku to do this just for fun. And then we'll do it both the Paku way and the manual way. Do I need a base 64 and code it would be my question. Because usually, yeah, usually you do have to base 64 and code it. Let's just try it. I mean, we have nothing to lose. It's all about experimenting and learning, right? Let's go to here, cd. Oh, we'll do nano script.sh. And now this will run by root by default. So let's just do like maybe make directory root SSH just in case it's not made yet. And then echo if we echo our private key in. Like that. My music stopped. Let's turn that music back on. Okay. And we do our instance IDs, which we actually have in Paku already. If we do Paku session Pwned Labs data EC2, instance IDs right there. Parameter validation failed. Invalid type for parameter. Do I need a base 64 and code it? Class bool valid types of bytes. Class byte array. I'll do it manually if I can't get this to work. All right. I'm just gonna do it manually. Probably learn more doing it manually anyway. So let's go ahead and copy this file. Actually, I'm gonna need that instance ID. And we'll just do mousepad Doesn't the SSH structure need a chmod 700 if you create it? It might already be there, but good call. If it doesn't work, we'll see if we can fix it. But if it's already there, we should be good. I'm just doing that just in case it doesn't exist. We'll just see what happens, and then we'll go back and play with it. And then I have to base 64 it. All right, let's go ahead and just get that part done. Base 64 user data, and we'll change it to user data b64.text. Instance will need to be stopped before you modify it. You have to stop it yourself or wait for someone else to stop it. Okay. Not a C2. Jeez. Come on, Tyler. Why do you keep closing stuff out, bruh? We'll just do this. Describe instances, profile, compute admin, region, US West 2, rep. There we go. What? Am I crazy? Oh, I need to specify the region, silly Tyler. There we go. Now I stopped it. So we'll pass the instance ID, attribute user data, and our file is this one right there. Here goes nothing. All right. I'm assuming we can change stop instances to start instances. Okay. Now I just want to see if the instance actually starts, and we can just do SSH as Ryan again at our target IP. Since we know that works for sure, because it sometimes takes the EC2s just a little bit to start back up. So let's just make sure we can SSH as Ryan, and then I will try as the root user. See, it's not back up yet. Or I just broke the whole EC2. Oh, there we go. Okay. Let's try root now. And it should automatically pass it my key. I'm root. What's up, y'all? I did it. And there's our flag. I'm too late. Just too late, y'all. Let's where did Pwned Labs even go? There it is. Boom. And I submitted the flag. Let's go ahead and look through the official walkthrough. Curious how different I may have done it. Sure not miss anything in chat. Thanks, y'all, for saying congrats. Appreciate the kind words. So, real world context, when with RCE, injecting programming code is executed, whereas with the command injection, it's an OS command that is being executed. This lab focuses on OS command injections, which are a common and significant real world issue in software applications, occurring when untrusted user input is directly incorporated into system commands without proper validation or sanitization. So we did all that. Yep, we did that, and then I kind of stumbled my way through that, but eventually enumerated the policy. Oh, that's just for the initial user. So I didn't even do that manually. I just assumed, hey, let me just spam EC2s and see what EC2s I can see, and it worked. I used Paku and the manual way. Yep, we nmapped it. Port 22 is open too. This one only shows 80, but 22 is also open, obviously, for SSH. We can try payload, such as command. So, multiple ways to get command injection. I did it differently. I did it with the backticks. Password. Moving on to root directories, you see non-default directory file backup. So here's what I did in different order. Before I even looked at file backups, as soon as I had RCE, I just assumed, hey, we have SSRF, we can probably get IAM cred. So I did that right away. The official walkthrough does a little more enumeration on the file system itself. They discover file backups, they get an RSA key. Cat it. Oh, they base 64 encode it first. That's what they do to do it. My way worked too. They get in, and so they don't even curl it. They don't even get the credentials until they get a full shell on the machine. I did that right away, just out of habit. That when you get RCE or SSRF, right away you should see if you can get credentials. So I did it right away. I did it in a little bit different order. Name compute admin is available. Yep, so I did all that. Added it to my account, or to my profile, created a profile for it. And then, yep, we did the same thing, except for, they said version 9. For me, it was version 1. Maybe the lab updated, but mine was version 1 if I remember right. And then, yep, we saw those same things. Leverage user data execute commands in the context of root, which is what we did. And yeah, we did something similar. So they set the suid bit on SH, it looks like. And as example, we add a command to create a copy of the root on binary and set the suid bit. So that would have worked as well. I thought mine was cooler, echoing my SSH public key in, and I could just SSH as root. That just seems cooler to me. And then yeah, base 64 encode it. We kind of followed the docs to figure out how to do that. We stopped the EC2 instance ourselves. We modified it. Now that's how I did it. Followed that basically exactly. We started it back up. They checked the private IP. The private IP didn't change, at least not for me. And they just ran that suid bit and they got root. But I did SSH. So defense. The shipment tracking page is vulnerable to command injection. This is because the user provided input is directly passed into the system function, right? Big no-no. Without proper validation or sanitization, allowing us to inject malicious commands and execute arbitrary code on the server. To prevent this command injection vulnerability, we need to validate and sanitize the input. A fixed version of the code that addresses it is below. The escape shell arg PHP function is used to escape a string to be used as an argument in a shell command. It has escape characters to the string to ensure that any special characters are meta characters. So let's go and check that out. The escape shell PHP function, I see. It's important. So it's kind of like when I was talking about the Go CMS, sanitize user input, especially here. It's important to note that executing shell commands based on user input should be approached with extreme caution. Whenever possible, it is advisable to use safer alternatives or consider a more secure approach that avoids directly executing shell commands. Word, I agree. It is also not advisable to update files in the web root or accessible subdirectories, as artifacts such as that can unintentionally be created that could provide attackers with source code. So if you would have found that using like Dirbuster, you could have read the source code and did a static code review and you would have discovered the RCE. Okay, let's check out this further reading. I really like that Pwned Labs adds like real life situations for each lab to the bottom. So look at this, a Facebook bug, a journey from code execution to S3 data leak. Facebook recruiting. I noticed the coding platform was not properly validating code and allowing to execute some dangerous code. What, they got RCE on Facebook, bruh? Yo, I bet they made bank. Wow. That is crazy. That's absolutely insane. Same there, I couldn't get reverse shell. What? That's intended functionality? So we took it the next level. Okay, very cool. Look at environmental variables. We found the f.py. Bypass the output limit. The true code is a script written in Python. It appears to be part of AWS Lambda function. Architectural level. This is pretty crazy. From a code review, I included the AWS. Let me zoom in so you guys can see this better. So he couldn't get to the actual credentials. Dang, this is long. Where does he eventually get to? Or she? I don't want to assume their gender. Shell script. Takes an encoded shell script and decodes it, saves it, makes it executable, and runs the script as a background process. This person really put in work. Especially after Facebook was like, no, that's intended functionality. This is inspiring, y'all. This person's way smarter than me, my goodness. Oh, did they get it? Boom, and they got the access key ID and secret access key. That's insane. I mean, it depends what permissions that has, of course. Oh man, I'm curious what they would have got for that bounty. So that's cool, y'all. When the vendor tells you not a vulnerability, keep digging. Oh no, they kept going. They kept going. And did they find an S3 bucket? Consider is Kevin's valid solution. And they downloaded a solution of another user. Oh my goodness. But it wasn't another person's user. Wow, freaking vendors, dealing with vendors. That's awesome, yo. Shout out Bipin Jitaya. I'm sure I messed your name up. Here's in cedar.ru, command injection. And in the API, you can actually see the ping right there. Cool, cool. Last one. RCE on system images. Okay. Just use to convert images when surfing. So taking control of the server. Very cool. We decided to award you the bounty. Nice. The domain does not contain any personal information, blah blah, hence the bounty for the domain is smaller because the overall impact is, it's still RCE. And they asked them to check to see if it's fixed. Oh, and they were still able to exploit it. Give this person a higher bounty, bro. They're doing your job for you. Killing it. That is awesome. So cool. Hey, if you guys haven't checked this out, HackerOne is an incredible resource to see some of these vulnerabilities being found in the real world. Ended up being a high severity. We don't see the bug bounty amount, but every once in a while, they'll actually disclose a bug bounty amount. I'm guessing this is a pretty good bug bounty that this person got paid out on. My highest bug bounty was $2,000 for basically website takeover. It should have been $10,000 in my opinion, but that's the highest one I've ever made personally, was a $2,000 bug bounty. So check out HackerOne, some helpful stuff there. But hey, for those of you watching on YouTube, hope you found this video helpful. Hopefully you found this walkthrough and some of the additional context helpful. Big shout out to Pwned Labs for another excellent lab, and I will see you in the next one.